Histograms and polygons. So a reminder, a histogram in stats basically is a column graph. And so when constructing the histogram, what makes it slightly different, we make sure the column is centered on the actual score. Sometimes you see those values called the bins. And we tend to join the columns up with no gaps, something like that. So from our example yesterday, there's the frequency histogram of our pets example. The cumulative frequency one would look like that. So it tends to go up because it's cumulative. The polygon in stats is the line graph. Now, what do we need to remember about this one is when we do it, we plot it in the middle of the column. So basically it's above the score like you would in any line graph. So it ends up in the middle of the column, like so. The other key thing though is we start the polygon at the previous one. So it's like saying the score of -1. Not that you'd get a result of -1 for the number of pets, but -1 and the score of 5, if you like, are getting a frequency of 0. And then we draw it in like that. Now there is a reason why we do that, because there is a direct relationship between the area under that curve and the probability of the thing. So that's why we tend to join those up. We'll see that later when we look at continuous stats. The cumulative one, that one we do a little bit differently. We start at the corner of the first one, right down the bottom there, and then we join them up to the opposite vertex as we go up. So that's how that one. And the cumulative frequency is sometimes called the ogive. Group data. Sometimes we've got so much different data that to plot every individual number is not practical. So we group them into classes. Guide to doing that. The classes have to be inclusive and not overlapping, because if they were overlapping, then you'd say, well, hang on, which one do I put it in? So it has to be clear which one it goes in. That means, therefore, that every score will belong to one and only one of the classes. But what happens if it's on the boundary? You just got to make a decision, and you make the same decision. So it might be, all right, I'm always going to place it in the lower group, or I'm always going to place it in the higher group. It doesn't really matter. As I say, you just got to be consistent for each one. How many classes are you going to have? Generally about 5 to 10. And the intervals then you can work out very easily. Well, the width of each of my class is going to be whatever the range is divided by however many intervals that I'm going to use. And if that doesn't come out to be a nice neat number, well then all right, we'll round it up and that'll be the size we'll do. Now, for calculation purposes, then you always assume that it's the centre of the class. Every piece of data has that same value. So here we go. Sample of heights. There are my classes. Every 10 centimetres, 300 students have been placed into those 8 classes. We're going to draw up our frequency table, find the mean. It'll be a median class, not a median, and a modal class, not a mode, the variance and the standard deviation. So there's my frequency. To work out mean, we need the fx as well. So remember, it's the sum of fx divided by n, or if you think of it in stats terms, the expected value. But in this case, we have to divide by n, because when we were drawing up, remember, expected value, we had probabilities in there. Well, this one is the actual value rather than the probability, so we need to divide it by the number of scores. As you would with any average, if you think about it. I'll sum them all up, divide by the number. 156.5. I'll need the fx squared column. Working out variance, it was the expected value of x squared minus the expected value of x squared. Now we'll work that one out. Again, that first one I've got to divide by n, and we get 262.75. Deviation is the square root of variance, 16.21. I'm going to need cumulative frequency. I'll work that one out. From there, all that information I can now, well, we worked out the mean was 156.5. The median class, and that's why I have cumulative frequency there, it makes it very easy to work out where the middle is. It's 150 to 160. The modal class also turns out to be 150 to 160. The variance we calculated, that was 262.75. And the deviation was 16.21. You got that. We worked out a median class. We can still work out the median though if we use the ogive. So there is our cumulative frequency histogram. Put the ogive in. We want to know halfway. Well, halfway is 50%. We've got 300 values. So that's, where is the 150th score then? So I could read across from 150 and go down. Now the answer is not necessarily 155. We just know it's in that class. But we can do a calculation for that. Here we go. We hit 150. If I make the use of similar figures, so I know then we have similar trapeziums here. So I know the distance from 150 to 99 over 199 to 99, so the small trapezium to the big trapezium, would be the same as the median to 150 over 160 to 150. It's basically just ratio of sides in similar figures. And we can calculate that out, and it wasn't 155, but it was very close. It was 155.1 we get as our answer there. All right. We shall add 15b to our list of questions.